My name is Tom Perry. I'm from New Leaf Design. That's my company name. I used to be a building contractor and energy retrofitter, and I'm now mostly focusing on trying to get the Zero Energy Now program off the ground. Zero Energy Now is very focused on Vermont's 90% renewable by 2050 goal. That's pretty much our entire focus, as well as trying to find an affordable and effective and happy in all respects way of getting homes off of fossil fuel. There's something like 240,000 of them that need to have something done by 2050. And so we have a lot of work to do. You can see the goal right up there. It's my sense is that it's looming in the darkness, or looming out of the darkness, a little bit like an iceberg dead ahead. And so we need to keep our eye on it. Chuck Reese, who is from Reese Building and Renovation, is my partner in this presentation. He is currently a building contractor and currently a energy retrofitter and also a Zen program certified energy contractor. Chuck wanted to talk a little bit about how Zero Energy Now, Zen as we call it, got started. He had a client who wanted to get off fossil fuel without moving out of her house. And Chuck thought it would be interesting to see if she could do it. And with that, I think I'll hand it over to Chuck.
Yep, thanks, Tom. Zen actually had its origins in a group called Building Performance Professional Association. And we had a discussion at one of our retreats where we would get together, the group of us, and brainstorm. And what came out of that was that people really aren't looking at houses in a more holistic, comprehensive way. And, I am not a builder that was very focused on historical preservation, but my focus was on energy. But we came to the understanding that if you didn't look at the house as a whole, you would not be including options that may or may not work for a particular building. So understanding how a house works energetically from the start was kind of what we came out of that retreat that we did. And that was kind of the beginning of Zero Energy Now. It wasn't called that then, but we were dedicated to looking at houses in a more comprehensive approach and figuring out how to get it to net zero energy. It's more of a performance base than it is prescriptive. So the goal was not to get the highest R values or to put most panels on the roof that you possibly can. It was to figure out how this house could get to net zero. So this house in Richmond presented itself to me. A client, her goal was, can we get this to net zero? So this is a next slide, I think, Tom. This is a house that is relatively easy to model, easy to start on. It was 1,248 square feet, 3 bedrooms upstairs. It was a 1907 house, so this would it's not on a historical register of any sorts, but it is a pre-World War II house, and I guess fits the bill for consideration of preservation. Had a stone foundation and a full attic. My approach to this was not to do this as a historical preservation house, but as how can we get it to net zero? But I'd like to walk through what we did, and then in retrospect, think about ways if we were considering certain things, what we could have done differently. So I'm just going to walk through this real quick. Next one, Tom. So it had a great south-facing roof, and that was one of the early signs for me that we can get this to net zero. It had a full attic that we could access to. Next slide. So we initially did the audit. That was the first thing we did. And the audit that we did was infrared and blower door. And I also modeled the house in terms of energy load. And that's probably one of the things that is a little different than some of the other energy audits you might get out of there. We actually, if you go through Home Performance or something, but we actually modeled the house and did a heat takeoff and figured out what the BTU load of the house was, and we could break it down from floor to floor. So I had a pretty good idea of what the house was, needing by way of energy to begin with. So next slide. So we did the results of the analysis we did was basically it really had a very high CFM 50, which means the blower door number was really high. The house is really leaky. It had a natural air exchange power of 1, just almost as bad as the one we looked at before. It used 650 gallons. The electric use was pretty low but she was a very modest user of electricity. So that's the result. That's our baseline. And then we looked at what we can do to make this house more energy efficient. And keep going, Tom. Next slide. So keep going one more. So we insulated the attic. We foamed the basement. That was, we can hold it here for a minute. That was a stone foundation. And again, this was before I was enamored with the idea of certain things to do and not to do with a historical house. But we foamed it. It did have some water coming in the basement, and we dealt with that by trenching outside the house and draining it away. And we were able to dry the basement out, and then we put foam on it. We also then covered it with intumescent paint. The basement was one of, it wasn't very tall basement, so it wasn't like a room that could be used for conditioned space down the road. Next slide. There was a wall that did have some foam on it. That exterior wall was underneath a deck that we restudded and or supported a little bit, and then foamed that too. Next slide. So this was after we did all our weatherization work, which also included, by the way, we did 4 windows that were really shot, and we did inserts. We kept the exterior trim intact, but we did inserts. There was a sliding door that was basically falling apart that we replaced also. So we considered this all part of phase 1, which was basically tighten the house as best we could. So we ended up reducing the air infiltration quite a bit. There's your pre and post. So the air exchange rate was cut down, not quite in half, but almost in half. And then we were able to monitor. She did this project over a number of years. We were able to monitor the reduction in oil just from doing that. And we did also some measures where we changed lights out and changed some equipment that was not efficient. So we would then get the post analysis of what this energy load of this house is, and now we could model that with the new CFM 50, and we can plug that in and actually get what the load will be after all the weatherization work was done. Once we had that, then we would go into phase 2. Next slide. So based on the phase, the information and what we might need, we also modeled what the heat pump load would be and figured out how many heat pumps. And then we knew how many kilowatt hours would be required for the heat pumps, and we knew what the kilowatt hours are for the plug load of the house. Then we put an array of solar on the roof. Again, that was a south-facing roof. There were pine trees there. Unfortunately, they had to go. She also wanted more sun in the south-facing windows for a little more passive solar gain. So they came down. Next slide. So that's without the pine trees. New little pine trees were planted, but there's the solar array. And we pretty much maxed it out on that roof. she was also considering electric vehicles. But we put as many panels as we possibly could, but it would clearly cover the heat pump load and the domestic hot water load too. We also put a heat pump in the basement too. I'll show you those in a minute. Next slide, Tom. Yep, keep going. So then the last phase was her to put the air-to-air heat pumps in, space heating and domestic hot water heat pump. Knowing the load of the house, we were able to do that. We put up internal units that were not in keeping with the historical preservation of the house, but we put one down and one up. Next slide. And that's what they look like outside. So from a where we have clearly changed the look of the house on this side with the solar and the heat pumps. And but next slide, Tom. I think it's a little backed up a little bit, a little closer. Yeah. So these are what they look like outside. Everybody knows what they do look like. We have the ductwork on the outside of the building, which is again not very attractive. Next slide. And then internally, we put a Stiebel Eltron domestic hot water heat pump, which would actually take the interior basement air and extract the heat from it. Next slide. So this house, after 3 years, we did achieve net zero energy on this house. So we achieved our goal. At that point, she pulled out her boiler, pulled out the tank for that, and backed it. She did have a wood stove, so she was using that as backup. And we were able to do this with a 1907 house. In retrospect, there are ways we could have done this without putting solar on the roof. She had a fairly large backyard, so if we were considering this as a historical preservation house and looked at it from that perspective, we may have considered that, to put a tracker in the back of her house, and I think that would have worked. We could have also moved the heat pumps down and had them side by side, and place them on a behind some screening of shrubs or something. And the foam on the inside, we did do another house in Heinsberg where we actually needed a drainage plane to keep the water away and down to a trough that was internal in the basement. And we used a drainage mat, and then we applied the foam to it, and that has worked very well. We could have done it on this house, and that would have been in keeping with the concept of something that could be reversible, that the foam actually attaches to the mat and not to the stone. But we found in our audits and our infrared that there was a fairly large amount of leakage coming from the basement and from the stone. So that's how we were able to get this house reduce the air infiltration quite a bit. We actually went to the attic and the basement and just did 4 windows. The windows in the front we didn't touch. I think we were talking about that earlier. So from the road, the windows, everything else stayed pretty much intact. So next slide, Tom.
Well, what is zero energy now?
And you're going to take this off and running there, Tom.
So I, again, wanted to focus on our program a little bit, but I thought it was important to understand how zero energy now works and what we're trying to do with it, and how it provides opportunities, I think, for what Sandy calls the scenic route as opposed to the interstate approach to weatherization and achieving net zero. Zero energy now is a lot of things to a lot of people, but the really important thing about it is twofold. With respect to the home and the individual homeowner, zero energy now is designed, it's a designed comprehensive approach to getting off of fossil fuel. And by that, I mean the focus is on fossil fuel. It's not specifically on any part of that process, such as tightening up the envelope or putting up solar panels. It's putting together a package that will get you to net zero. And beyond that, beyond individual houses, it's a program that links the existing market that we have right now to our 2050 goals. And, the next question is, if we have all this stuff out there, why do we need zero energy now? And I answer that question by asking another, why are we so reluctant to get off of fossil fuel? Aside from this group, which when dealing with historic buildings, perhaps has very good reasons for wanting to take a serious look at exactly what we do, we're mostly, I think, reluctant because we're confused about it. We're not sure how to do it. We're afraid of being sold a bill of goods. We're not sure it will work. We're not sure we'll like it. We know it's expensive, and we worry about being able to afford it. And, people aren't doing it. I mean, it's just, we don't want to have to be the first ones to do it. And I think we all feel like it's really something that the government or somebody should take care of. It's hard. It's full of those kinds of dilemmas. And I keep, as another year goes by, the first time I started focusing on this 2050 goal was about 3 years ago. And it's still out there, and it's still looming in the darkness like an iceberg. And we need to focus on it. And I'm not kidding when I say iceberg, because we're going to start seeing things like this floating into New York Harbor if we don't start taking action sometime soon. But the good news is Zero Energy Now really addresses all these concerns. It provides a clear step-by-step strategy. It's customized to the house and the homeowner. We are using technologies that have been around now for several years, and we're learning enough about them to design careful projects with them. And the incredible thing is that we really can find affordable solutions for most people to get off of fossil fuel. We can take advantage of incentives. We can make it accessible to every homeowner. And if we get enough action going on it, we can build climate-related businesses. We can grow jobs. We can invest in our existing buildings and in the local economy. It's the kind of thing that Republicans and Democrats alike will be happy about, and the government should be on our side about it. So Zero Energy Now is 100% focused on Vermont's goal of becoming 90% renewable by 2050. And we're realizing that in, what is it now, 29 years, we have a lot of work to do. And the obvious thing is that we have to get off of fossil fuel, and we have to embrace renewable energy, and we have to do it in a way that's affordable for the homeowner. If it's not affordable, it's just not going to get done. So basically, we found that through this multi-pronged approach that Chuck was talking about, combining weatherization and super efficient mechanical systems and renewable energy, we can get incredible depth in our energy savings and incredible depth in our cost savings, and that is what makes the program affordable. We have to start by understanding the house as a system, getting all the essential components together, the passive systems built into the envelope, along with the active heating systems, and the potential on-site or through other options for renewable energy. And if we use these systems together, we can get terrific results. And it's not the envelope really that has to do the heavy lifting. It just has to do its part. So Zen is not a deep energy retrofit. It's a strategic energy transformation. And it's fairly straightforward. We begin by tightening up the envelope as much as we reasonably can. And then we apply the super efficient renewable energy based heating equipment. And you can see how by doing that, we drive the fossil load down. In this case, the fossil load started out up near 80 million BTUs, but after this project, it was down to probably 3 or 4 million BTUs. This was a real project that we did in 2016, and this particular homeowner was using quite a bit of wood initially, 40 million BTUs about of wood heat. And over here, what he did, he took out the oil furnace, or he didn't take it out, but he basically stopped using it and supplemented the wood with heat pumps and solar. And so it looks like his renewable load is a little bit higher, but his wood usage is cut in half and his oil usage is sharply reduced. The Zen design process involves coming in and taking a look at the house and doing an assessment, and then collecting all the data, which means measuring up the house and getting fuel usages from the oil dealers and the utilities, and then putting all this information together and applying it in our design tools and our modeling tools. Understanding the house as a system is basically seeing how all of the energy flows through the house, what it's taking for heat, what can be gained by improving the envelope, how much we can expect to gain from that, and then we can design our heating systems to accommodate that hopefully reduced load. In terms of collecting the data, we, contrary to what has fallen out of fashion, which is, a close energy audit, we feel that we really do have to do a blower door test. We have to get the details of the envelope. We have to measure up the house and the heating equipment efficiencies. We really need to get fuel usage 3 years prior, most often directly from the fuel dealer. If we do that, we can get really good data, delivery to delivery with costs and quantities. And then in our design tools, we can correlate that to heating and temperature, heating degree days, and weather data, and come up with good values for our heating load. We also have to get the utility data for a similar period. And the best way to do that is directly through the homeowner's utility portal, if possible. We have 2 tools that we're currently using. We use QLOS, which is a tool that was developed by Vermont Energy Investment Corporation, VEIC, which they use to develop some of their modeling tools that they use in home performance, HPro and Hero and so forth. And they're using it now for with builders who are dealing with small commercial buildings in their building performance program. We use it with our program as a way of basically modeling the envelope and the envelope improvements that we've come up with for our envelope work scope. And we then can bring those into Clear, which is our in-house design tool. I'm going to put the zoom scope on this just so that you can see it a little bit. It's a very basic modeling tool. It's not terribly sophisticated. It's basically a UA delta T process modified somewhat to get slightly more accurate R values in walls and for windows and other surfaces. But we what we end up with is an existing envelope load, and that would be a post-efficiency envelope load as opposed to a consumption envelope load. And this is important because we're going to be installing new heating systems most likely, and we need to know what the load of the envelope is. We don't want to have to subtract out the efficiencies of the equipment before and then apply new efficiencies from the new equipment. So we're looking to get a straight envelope heating load. We then plug that into Clear, and Clear is basically a very comprehensive design tool that combines the essential data about the house, the envelope load details derived from QLOS, with existing fuel and electric usages. And with that, we develop a snapshot of the existing energy use and loads in the house. And then we basically take the envelope work scope from QLOS and apply that number. I'll use my magnifying glass again so that we can look at this just a little bit. This is all very normal data. It looks like an awful lot of stuff to enter in, but it actually, once you have the data accumulated from your site visit, it actually is very quick. I mean, a lot of these slots you don't have to fill a lot of times. So Clear has multiple pages. This purple one is the project data input page, and this includes all the information for the envelope improvement, the existing heating system information, the proposed systems that you're considering installing. And then I couldn't fit it on the page here, but there's space for putting in inputs for domestic hot water and any improvements you might be making there. And then a place where you can basically account for all the other appliances in the house, which include the, your kitchen appliances and things like dehumidifiers or washers or dryers or whatever, as well as any fossil fuel appliances. If you have a propane cook stove or a propane dryer or something, or gas, natural gas, you would have a place for those there. It's important to account for all those loads, because what you're ultimately going to be doing, you're going to be probably adding substantially to your electric load by putting in some sort of heat pump system, or not. You might be going with biomass, but you need to know exactly what your electric loads are going to be, because you're definitely going to be applying some kind of renewable electricity to carry the loads in your house. That's the essence of Zen. We have other pages here. This one is devoted to incentives. Again, I don't show the whole page, but one of the real benefits of the Zen program is that it can leverage incentives from Efficiency Vermont, from dealer and supplier based incentives, where your heat pump contractor gets a discount, an incentive discount that he passes through to you as a homeowner. And also some of the other utilities are offering pretty amazing incentives, both for equipment and in some cases for weatherization. Of course, it varies. Vermont Gas is different than Efficiency Vermont. Burlington Electric, for example, offers, I believe, $10,000 for his major weatherization job, which is very, very substantial. So it's important to be able to keep track of all of these various incentives, and CLEAR is updated to do that. This page up here is where fuel data is entered. There's kind of a scratch sheet where you can plug it in from a PDF from the fuel dealer or an Excel sheet, and then you can transfer it over here where it gets correlated to the weather data for that particular period that you're trying to get your data, your energy data for CLEAR. And then this page here is entirely number crunching. On the left side is your existing energy situation, and on the right is your proposed. And that takes you to the final page, which is a summary and report page, and you can compare your home's current energy profile to your home's potential energy profile. And our goal is always to look something like this. Sometimes we don't go quite this deep, and we'll take a closer look at it when we look at the Victorian and Bellows Falls. But you can see here, all this black stuff, this is fossil energy use. This is energy dollars and how it's divided up between fossil and grid electric. Those were the only two things that were part of the house at that time initially. And then this is the carbon emissions. And I can, again, put the magnifier on it, and you can see a little bit more closely how those loads come up. This house had a very, very high energy bill, over $4,000. The total energy load was probably close to 175 million BTUs, very, very high, which meant basically that this house was a really good candidate for the Zen program. And you can see this person did a combination of the gold here is biomass. It's a pellet stove. And then he had two heat pump systems, a multi-head and a centrally ducted heat pump, which work in combination. And the only thing, he didn't have enough space on his, he was going to put the solar on his barn roof, and he didn't have enough space to cover the whole load. So there's still a little bit of grid electricity here, which it's the bulk of his energy cost at this point. But you can see in particular, because electricity in Vermont has very, very little in terms of carbon emissions. His carbon emissions are way down near zero. He did this project himself. He GC'd it himself and was on site doing a lot of the work, so he was able to save a lot of money. His envelope work scope, for example, is only $6,000, which is probably a little lower than average. But he's got the multi-head air source heat pump system, centrally ducted heat pump, and then the pellet stove. And I think he's kept his boiler there, but I don't believe he was anticipating using it at all. We didn't have it showing anywhere, but it's still in place, so I left it as part of the systems. And then he has a heat pump water heater going in as well. Total of all of those mechanical improvements, he had to pay a plumber to do that work is $16,000. I should point out here that the project cost is pretty high, $39,600, which is not something that is easy to sell to anybody as an energy improvement project. And so you really can't look at it that way. Instead, you want to look at it in terms of your financing and cash flow. And he was able to get a low interest loan, just under 4% through Vermont State Employees Credit Union, a 15-year loan, which gave him a very low monthly payment, which, along with the energy cost over here of only $95, came to considerably less than the pre-project monthly energy cost of $340. So this project, even though it costs this much and that he had to finance over $20,000 of it, will actually cost him less to live in the house than it did before. And you can see, again, the load reductions. The envelope work that he did was huge, very, very significant. And that contributed greatly to the fossil and grid energy reduction. And the renewable component is a little bit less, only because he didn't have the space on site for the panels that he needed to cover it. His monthly savings would have been greater if he'd been able to get the load all the way down to 100%. So that's basically how the Clear tool works and how the program works and how it develops projects. Chuck, were you going to take it back from here?
I noticed, Chuck, Tom, that Alex has raised his hand. Alex, did you have a comment or a question?
Yeah, Tom, and just kind of looking at all this, I'd be curious to kind of know, it's a bang for your buck kind of question, right? Of how much energy reduction are you getting solely through more efficient appliances, more efficient heating units, and the cost that goes into it, versus how much energy usage reduction you're getting from weatherization and the amount of cost that goes into that. And that, I think, is kind of leaving out the other thing that we've been talking about is, the potential risk to the historic fabric of the house when doing some of these weatherization projects to the envelope.
Mm-hmm. That's a good question. I guess what I'm hearing you ask is, if we were to scale back a little bit on some of the weatherization measures, would we still come out with a good project?
Yes.
And I think, I certainly think you could. As Chuck was mentioning one time when we were all in a group talking, what happens in that case is you have to basically increase your heating capacity, which means that you need to increase your renewable capacity. And so there's some additional costs there. We have never in this program emphasized the weatherization component all that much. The program was originally set up with a 10-50-50 set of standards, 10% envelope improvement, 50% grid electric and fossil fuel reduction, and then 50% of your after project energy usage had to be renewably based. So our standards were kept purposely low, partly because we didn't want to scare people off too much, and partly because we thought once we got people interested in the program, they would, see how far they could go. I think we both scare people off, and they also are afraid to go any further sometimes. So it's hard to say, but what we're still learning is how do you sell this product? Because as I pointed out, the costs are so high, it's very easy for people to get fixated on that and say, gee, thanks, I think I'll pass. And the other things, of course, we're dealing with, for most people, pretty significant debt, and it's a challenge to get people over that particular hurdle. And so, but one thing I do know, we have an optimization tool built into Clear, and it's something where you can just plug in, check off, try to get another 10 or 15 million BTUs in envelope improvement, or try to do it by putting in another heat pump or by putting on more solar. It's very hard to push the envelope to thicken your savings through those measures. It's generally more costly beyond a certain point.
If I may add just a little bit to that, Alex, the optimization tool in this particular analysis is probably one of the real benefits of going through a program like Zen, because you can change things and plug in cost and savings and figure out what's the best way to achieve, most cost-effective way to achieve net zero. And with historical preservation, some things are off the table. We're not adding 6 inches to the outside of this house. We may not do the windows. We may put storms on, and if you can generate costs for those things, and you can plug that in, and you can figure out what's the best way to get that. And a lot of times, like Tom said, it's not with putting all new windows in. It may be putting 3 more panels on the roof, or upsize your heat pump from a 12,000 BTU to 15 in a particular part of the house. So that's really the analysis that's been missing all along, to figure out how a particular house, this unique house, can get to net zero, or to achieve savings that we really need to hit our energy goals.
That's what I think is so great about this system, is that you can add those optimizations and your own kind of, things that you do not want to change. And then you can kind of play around like, okay, well, what happens if we change the windows just on the rear of the building, or, whatever it is. That's what I think is so great.
And that requires modeling and doing some of the, the Q-loss stuff. And that's not what people been doing, when you're getting an analysis done. So that's what this program would do. And I think I saw somebody on chat asking what this all costs. And we still have to go through Efficiency Vermont's home performance to get those incentives. So that's like $400. But I think we're working out in the Zen program to hire folks that are called coordinators, where they would actually run a more comprehensive analysis through the Zen program. And I don't know what, we haven't selected on a cost for that, Tom, but I think that would be in the neighborhood of $200 to $300. So for an additional $200 to $300, you would have this analysis. And in that analysis, then you could change the variables and say, what if what if we do the tri-pane in the back, or what, or what if we, put another 10 inches of cellulose in the attic, or whatever. That to me is how we find out the best path for a particular house to get to net zero. So just like we were talking about, examine the envelope, and we really look for the low-hanging fruit. And in some of our weatherization language, we refer to it as tops and bottoms. So the easiest spot to get to plug up holes and add insulation is the attic and in the basement. If we were to pick, if they said pick 2 spots in the house where you would go and not look at anything else, that's where I would go. And also, we do a lot from the inside, so it's not affecting the outside as much. And I know, we use not a fair amount, but we air seal with foam and then use cellulose to get the R values up there in the attic. And then in the basement, it's primarily foam. And I know I'm not a big fan of foam myself. In all the new homes I build, I use foam only when I have to. And that's kind of the same approach we take for weatherization. We use it only when we have to. And then other opportunities are looking for irregularities. Windows like in this house in Richmond were really just totally beat up, and we had to replace them and pull them out, but we were able to save some of the trim. There are some structural things that may have to be repaired, and if we repair those, we air seal at the same time. So again, our program is mostly based on the weatherization heating load. And once we figure out the load, that opens up opportunities for us to size the system, to determine how many solar panels are going to be going on the roof. Without that, I think people are just shooting blindly as to what their house may or may not need. There are some rules of thumb, but if you're really trying to fine tune and make this cost effective, having a much more detailed analysis of what the house needs and how to best satisfy that, it's a combination of, we call it a 3-legged stool. You have weatherization, renewables or solar mostly, and then thermal with the heat pump. So those 3 things combined is what we try to balance and figure out what's best for that particular house. Next slide. Yeah, we kind of just covered that. Okay, next one. So heat pumps are how we've been doing a lot of the thermal load. When we're basically shifting the thermal load to electricity, and sizing the heat pumps according to the house is kind of critical. And we do model this, and we have design temperatures of -5. And Mitsubishi has just recently came out with another model of their mini splits that basically is now full capacity to -5. It used to be 5 degrees above zero, but now they have got it to be more efficient. So I have been having pretty good luck with getting existing buildings to pretty much heat most of the time with heat pumps. And there are some exceptions to that, because some houses you just can't get the heat from heat pumps distributed to all the different nooks and crannies of the house. And we sometimes use thermal transfer fans to do that, and that's been pretty cost effective. But you will need to probably do a combination of heat pumps and wood stove or some kind of other renewable energy if it's shifting to net zero energy. And we have on occasion used resistance heat too. And that would just, all these things, if you use resistance heat, that's just gonna make your PV load higher. So that's how you balance all this stuff. But for the most part, air source heat pumps is how we've been doing that. We've done a couple of ground source heat pumps in some of the buildings I've done with geothermal in particular. So next slide, Tom. So we'll just power through this, Tom. These are just some of the options that we were looking at for, existing homes and historical homes in particular, aside, and we'll go through some of the split systems first and some of the interior. So that's your typical interior head for a mini split. And I don't know many of my customers say, oh, that is really attractive. I really like that. Some of them don't mind it. Others really don't like it at all. Next one. So you can switch to a unit like this that is wall mounted. It sort of simulates a radiator of sorts. So I do have 2 customers that I've asked for that. They like the looks of that better, and it can blend in a little better. Next slide. And then you also have the cassettes on the ceiling. If you wanted to use those, I mean, you still see them, but they're not as much of an eyesore as some of the wall mounted units. Next one. And again, these wall mounted, they come in different sizes. You can put them right down so they do look like a radiator. Next one, Tom. I think this is a slide Alex had earlier. So it simulates the look of a radiators, but a little more modern, I guess. Next slide.
Nobody's going to be fooled.
Yeah. And then you can, if you need to do some woodwork or something to hide these units. This is an example of something that's hid behind a removable wood grill that you can actually pop out and clean the and it takes away some of the obviousness of a heat pump that's mounted high. And usually the heat pumps are mounted high on a wall like that. Next one. And outside, there's not much we can do. I don't see how we hide these to look decent. And the best thing I can say to my customers is, what side of the house do you not want to look at? Or where are all the utilities? We'll stick them over there because they got to be there anyway.
You can concentrate them in a ghetto in your one part of your house.
And it's also, for existing homes, they typically run out ducts up the outside of the house, so they're not that attractive. Sorry. And then to try and get the line sets inside the house is going to, be much more expensive. So typically we put them on the side of the house that doesn't look so good or is not like front and center, driving up, and we try to, consolidate them into one area. Compacted ducted heat systems. I have not put many of those in. Next one, Tom. But you can actually have a unit that blows the warm air and then can be ducted from a small unit that's either in a chase area somewhere, and those are an option too. Again, that's going to require building ducts and and delivering. You can deliver heat to different rooms, but you got to get the ducting in there. They are generally more efficient than a multi-head split system. The multi-heads are not, I have steered away from them. I don't find them, we've had some analysis done and they actually are less efficient than the mini splits too. And also can be cheaper than multiple splits, but that's one option, I guess. Next one, Tom. And these are the centrally ducted systems. And it's basically it's basically one big system that's run either in a conditioned space up in the attic somewhere, and then it's blown to the various rooms. They tend to be a little more expensive too. With an existing house, you've got to have access to the rooms, and if the house you're working on is all one level, that might be easier. You can put it up in the attic, but you really do. I think it's an expensive option personally for an existing building anyway. Yep.
You can, in some cases, tie it into existing ductwork. It's something that should be done with caution because forced hot air systems operate at different pressures than centrally ducted heat pumps. But I had one contractor who put together a proposal for using existing ductwork in a house to install centrally ducted heat pumps.
So Jay just chimed in on the chat there saying that he runs some of the ductwork in the interior of the house. And I kind of like that idea. And I would imagine that might be less intrusive if you're focused on the outside of the house, but
Is it new ductwork, Jay?
Yes, it was new ductwork. I had one project where I was not aware of that, and the client wanted so many heat pumps to serve every room that when we got done, it looked like a mess. And then later I learned about the ability to put in the valve boxes inside, which saved a lot of the cables going up. And now I won't do an exterior job now because I think it really ruins the look of the building. They have these ugly white cables up. I think the whole industry needs to get into the aesthetics and not just the energy.
yeah.
And really try to give
Yes.
us more choices for interior units, better proportions of them, maybe longer and not sticking out so much. And I also find a lot of clients find them very, very drafty. So I think it's important to make sure you don't have them blowing on any people sitting in an office setting. It just, it's sometimes just unworkable to sit under those units because they're just simply too cold. I had one project where the conference room was a problem that they couldn't really use the conference room if the heat pump was on because it was too cold, too drafty. But it can be a problem if you're not careful. I think it just is the issue of often the air is just blowing too fast, and if it's cooling, it's too cold.
Yeah.
Yeah, that's a particular problem in bedrooms too, Jay. I now ask my clients when we're building new houses, where you planning to sleep? And then we locate the interior head. Yeah.
Well, I've had some projects where I've actually found, talking to the engineer who was going to install it, and I asked him to just change locations of several of the interior units. The cost was really not a bit more, just that he didn't think about that issue.
Yeah.
But I think it's still a growing industry, and it's focused so much on energy savings that, in Burlington, they're increasing electrical rates 7.5% just because so many more people are using heat pumps. And it's like, I think they also need to focus on the aesthetics, and, we're focusing on the preservation issues in, today mostly, but I just think there needs to be a little bit less concern about what color white plastic it's going to be and what the shape of the units are.
Mhm.
This is Rick Kirshner with a question. I know that the interior units are fine for large open areas for many of the reasons you've just been stating, drafts and the like. But when you have 3 bedrooms upstairs in that Richmond house, Chuck, did you have to put one small unit in each bedroom, and did the units come small enough so that they don't cause problems?
That's a really good question, Rick. We put one unit in the larger bedroom, and we talked about doing transfer fans to the smaller bedrooms, but the owner opted just to keep the doors to the rooms open, and that seemed to be. And they also liked the upstairs to be cooler because that's where they sleep. So that seemed to work fine.
Okay,
So,
yeah,
How many occupants in that house, Chuck?
there were only 2 at the time.
yeah.
Yeah, and now there's 1. So yeah, I think based on her particular needs for the house, that seemed to work fine for her. So yeah.
Essentially, you do sacrifice some comfort. People are used to having each room comfortably controlled, and as long as you don't mind being cold or hot in those rooms without the heads, then it can work.
Yeah, there might
I don't think
be.
being cold or hot is a problem. I think people mind being cold or hot.
I do too. That's one of the things that's keeping these to be integrated a lot more into historic houses where you have smaller rooms.
Again, that may be a behavioral thing. Again, if we're keeping our goals in mind for energy, they can put transfer fans in, and it costs more money too. But we can move air around upstairs, no problem. And we did one house in Middlebury that, this goes back to a question earlier, that it was tightened up enough that we had to put in an ERV. Unfortunately, we were able to get to the bedrooms with the ERV and distribute that. And then that ERV was also able, at so many minutes of an hour, be put into recirculation mode. And that was moving air around in the house from the heat rooms with heat pumps. And that seemed to work okay too.
That's a good idea.
Yeah.
In the old days, we used to just put on a sweater.
All right, let's keep moving.
I don't know if anybody does that anymore.
Next one, Tom, let's move through this.
Sure.
again, do you want to address this one more, Tom, or
Sure. Air to water is just another option. It's probably is a little bit more problematic in existing homes because it's designed to operate at lower temperatures. It can't be used with hydronic baseboard, for example. Works well if you happen to have radiant tubing, radiant floor kind of heat in your house. Otherwise, most likely you would have to upgrade your distribution to have radiators that had more area than hydronic baseboard and could heat a room with the lower temperature water. I thought that might be something that could be improved upon, but I've been told that it really is not something that can be improved upon. The other thing about air to water is it's probably quite a bit more expensive. It's hard to beat the cost of split systems. You know, there's going to be extra cost for distribution, but one of the advantages is it can be coupled with domestic hot water, and it can function with air-to-air AC. Mitsubishi has models that will actually do that. Ground source heat pumps. You have some experience with that, Chuck?
Yeah, we've done this with existing buildings. It doesn't. It's kind of hard to do it for existing buildings because most of the time when we're using ground source, we do it with radiant heat inside, and getting radiant heat other than a basement area is kind of difficult. The ground source, if you do put in a system ground source heat pump, depending on, it's the source of it. It could be water, it could be in the ground. There is a federal incentive for that of 27%, I think it is still. Yeah. So there is some financial motivation to do it, but it's really hard to do it with existing buildings. We do it mostly with our newer buildings, but there are so many options. And if people are more interested, want more information, just you feel free to contact me. But
the Zen program has actually enrolled at least 3 ground source heat pump projects, all through integrated solar down in Brattleboro, I believe. There may have been one done by another contractor. But of course, the main problem with them is they're expensive. And if you are trying to do it with an existing property, you have to dig up huge parts of the property, or else put in a water well, which is, if you're doing that anyway, it can be a compatible enterprise with that. But again, it can be coupled with domestic hot water, and it can also be compatible with various heating distribution systems. I think you can use it with radiators, can't you, Chuck, or not?
yeah, yep. They do make a couple of radiators. You can also use it. They call them convective fans, where you can have the heated water moving right through a fan and blow it into the room. And sometimes that's easier than running ductwork and doing that kind of thing. Yeah. But then again, you've got to get into the walls. You got to get the pipes to the rooms. It gets very expensive. Tom, somebody was asking the difference between air to air and air to water heat pumps. You want to go
air to air? You're basically delivering air from outside the building to inside the building that's been concentrated to heat your house.
Yeah.
Air to water, you're using the outside air to heat water that you're running through your water distribution heating system.
I don't have any numbers on which one's more efficient, though, so I would like to know that, but I would imagine you're circulating water, so you have that energy to circulate the water.
Yeah, there's some kind of heat exchanger effect, and there are two different types of air to water, one that has the unit outside and one that has it inside. It's worth learning more about, but
Yeah.
I don't have the information,
Right.
the specifics on that.
Let's just
Now-
power through this, Tom. Yeah. Because
We
I
can
think,
move on to biomass.
yeah,
That's an obvious one.
these are both wood. And that's an insert. If we're going to do wood in a fireplace, we need to have it air sealed and makeup air brought to it, or else it's just a blowing your energy up the chimney, and it's a net loss to the house. So we haven't done many fireplaces in existing houses at all, and mostly I recommend people just put an insert in and put a wood stove in place of that, or don't use it. These are pellet stoves, these guys. Pellet is a nice backup for heat pumps. When the house temperatures, or I mean, when the outside temperatures get below -10, -20, the heat pumps will lose efficiencies and may not be able to keep up. So it would be necessary to consider some kind of backup. And pellet, I think, would be, the efficiency of the pellets are pretty high. So I think that might be a reasonable backup. And they do make pellet furnaces too, but I think that's the next slide, Tom.
Yeah, I just wanted to say, for pellet stoves, if you're not familiar with them, check them out, because some of them make quite a bit of noise, and they also use quite a bit of electricity, and they require power. They can't be, used by hand like a wood stove. That must be a pellet insert.
That's a pellet insert, yep. So there are biomass options, and this is a full system that's a pellet furnace by Pellergy, which I think is a Vermont-made company. And that is possibly can use the existing ductwork if you wanted to move your thermal plant to renewables, and heat pumps don't make it for the type of house you have, but also you can utilize the ductwork that's existing with these. They tend to be a little expensive also, but that's a good way. And I think, John, one of the houses we've been looking at is considering going to a pellet furnace, if I'm not mistaken. And I believe this is a pellet boiler where you can then, circulate the thermal energy through the pipes of the house. That may also be able to use existing pipes that are, if you have baseboard hot water, because the temperatures do get up pretty high in that. So the last two are systems that may be applicable to a house that is going to run on renewable, but it's going to be biomass. I do have some issues with shifting a house completely to biomass. They say it's carbon neutral, but I have seen research that indicates that it may not be carbon neutral, because the amount of carbon we're releasing when we combust wood is accelerated well beyond what would happen to that wood in a forest. So I would be careful to say, we're just going to shift our houses to wood and reach our carbon goals, because I think I honestly think the best solution may be doing most of the heating with heat pumps, and then maybe do some backup with wood, pellet stove or a wood burning stove, a cordwood. So those, in my mind, is kind of where I would like to steer my clients to, if they're concerned about the heat pumps not keeping up with the heat, the thermal load of the house on really low temperatures.
One thing to consider about biomass in Vermont particularly is that it supports a local industry. And I tend to agree with Chuck, being skeptical about biomass being carbon neutral. In fact, somebody I spoke to, and I don't remember who it was, and I don't remember the amount, but they actually put a percentage on it as to its, how much carbon it produces. And it's something certainly more than zero, beyond what, would ordinarily be. It's far less than fossil, but certainly not zero. But again, if you consider that a lot of people just aren't going to want to deal with it, that it does support a local industry, I think there's room for, limited biomass as a way of getting ourselves closer to net zero.
Tom, we have a couple more slides, and then before you're going to go into the case study.
Yeah. Domestic hot water, do you want to say anything about that?
Just a couple of things. I used to install solar hot water, and I've had a bunch of issues. It was on the roof. They need to be on the roof. It's really hard for them to be, adjunct to the building. And we've had, pretty good luck getting water temperatures up. It doesn't work that great in the winter, obviously. And we've had some maintenance issues with them. The glycol in the system has to be tended to. And I have since moved completely to just putting the domestic hot water heat pump in the basement and having it, take the heat from inside the building. And in terms of making it renewable, that heat pump may require a panel or two more in terms of the PV array. It's also parasitic in the house basement, so it may absorb some of the heat from the heat pumps wherever they are in the house. So that seems to be a better system for me. And for historical preservation, putting heat pumps, solar hot water heat pump panels on the roof are I think a real eyesore. So that's kind of where I'm at with domestic hot water. It's mostly been all in the basement as a heat pump.
One concern about heat pumps is there's a lot of noise associated with them. They also take quite a bit of time to recover, I believe. So like they would have to run for a lengthy period of time. So you want to think about where you have it set up, and maybe in a basement it's fine, because you don't mind the noise being down there. But I have heard complaints from people about the noise when it wasn't located well, and also the recovery time is sometimes problematic. So people have to be sure they size the system properly.
There is a advantage of putting them in the basement is that they do actually pull moisture out of the air. They are that's just the way they work. They need a condensate line, and over time it can reduce the moisture levels in a basement. That's another advantage of them. All right, next up.
Other appliances?
We were thinking of, I'm not sure, I think you read this slide in, Tom. What were we thinking of on this one?
Well, just there are always opportunities for improving your appliances as part of your energy load reduction, and just being aware of them as they contribute to your energy load is important for sizing the solar.
Yeah.
If you make changes, for example, if you take out a furnace, which is using 900 kilowatt hours a year to run circulators and stuff, then you want to take that load out. And if you're putting something in, like a pellet stove, which uses, something like half that, you want to put it back in. So I guess I said that in this slide here. But make sure your solar contractor is aware of what you're doing in the house. and the changes you're making to your loads so that he or she sizes the system properly. Should be obvious, but for some reason it's not.
Hi there. I really appreciate you guys' presentation and the work you, Tom and Chuck, are doing. I think it's really neat. I'm down here in southern Vermont, and I have endless questions about this sort of thing. But as a builder down here, focusing on more high efficiency building, I do find that if we improve the envelope, there isn't a need for, we can put have single source heat. You have a single heat source in a building. I mean, I was fortunate enough to build my house, and I have a tiny wood stove downstairs, and because I have an HRV, I'm circulating my air. It's all I need. The upstairs, the boys' room is perfectly fine. And I think it's important that, I know we're focusing too on historical things, but if we can really focus on air sealing and keeping the envelope tight, and there's not a need for like heat pumps in every room. Like, people were able to build in such a way, if we can focus on the envelope, where we don't have to fill the whole house with heat pumps. And I think it's really important that we're focusing on this air sealing approach, is along with the thermal. But it's really important that we're using mechanical ventilation, especially now with COVID and with air quality, that we can't just get away with being like, we're going to leave like a hole here or there in our envelope, and that's going to be our fresh air. And I really, again, I just wanted to comment and say that, I really liked you guys' presentation, and really appreciate the work you guys are doing.
Thanks. Thank you, Jethro. And just so we're clear, we always go to air sealing and thermally improving the envelope first. It's we do what makes sense for that building, but if we need to add 20 inches of cellulose and we can do it, we'll do it. What makes sense thermally, but also, what's going to make sense for the building itself. That's where we go. And you're right. And I think you hit on another topic is, and I think Tom alluded to that, we used to wear sweaters. If we are achieving a goal in a world that is getting warmer and warmer and warmer, we may not be able to be as comfortable as we like in every room. We may have to deal with that a little bit. And, I think there's some behavioral changes that are down the road for us also. And part of that may be that our rooms are a little bit cooler, or the upstairs are a little cooler, and you keep doors open, and and we also avoid plastering heat pumps all over the exterior of our buildings.
And have you found, just real quick, have you found is there ever, like, if you're doing new siding, like say you have to do new siding, and for whatever reason, like the windows are bunk too, have you found that doing exterior insulation can make sense?
Yeah, that's really true. Exterior insulating from the outside with foam, no. I haven't done that, and I don't think that makes a lot of economic sense unless you're really pulling all the windows out and you're doing a major rehab. We would insulate from the exterior if the cavities of the walls are empty, and we would remove a single piece of clapboard and blow it in. That makes total sense, and then repair. But putting foam on the building for a retrofit, if we ran the analysis on that and did the optimization on that, it wouldn't make sense.
If I could just say something as a small aside without derailing the conversation. I have a old house, and it's, I think, almost 3,000 square feet, which is more than, it actually has 2 apartments now. But when it was one family house, I could heat almost all of it with one pellet stove. And that was simply because we weatherized the building. And as I said before, there's no insulation in my walls.
Wow. That says a lot, Sandy.
We were comfortable downstairs with just sweaters, and I always made my children wear slippers. Mm-hmm. It's amazing how many people in Vermont think they should go barefoot in the winter in home. But
Sandy, that's
it-
an argument for running the analysis on your building, because you would just
Yeah.
running the analysis would have told us that, we may not need that many BTUs to keep your house at a comfortable temperature,
Well, I also just want to point out to the other designers in the conference that one reason why one pellet stove worked in a house of that size is that we have 2 staircases. Many old
Yeah.
houses do that. And I found that it makes it actually quite an important difference in getting heat upstairs. And the other thing was that we let the upstairs be cooler. The hot air naturally wanted to rise up, but it was kind of maybe in the 50s upstairs, and downstairs, could be quite toasty around the fire. So there was definitely temperature gradations.
Sandy, would you, on occasion in the winter, sit on the stairs?
No, we never spent time in the stairs, but we would sit very close to the stove.
I was gonna say, if you did, you would feel air moving down.
Yeah,
from
Way
upstairs.
too dry. Yeah.
Yeah, so the air circulates above you on the stairs, and the cold air moves down. It kind of
Right.
does it naturally, convectively, yeah. So let's jump into renewables before we go to the case study for you. Is that right, Tom? We'll keep going here. All right. So when we talk about putting in heat pumps and getting ourselves renewable, we're really talking about switching to electricity. So if we're gonna be a net zero energy house, we are mostly talking about solar PV. There are other renewables also, like we talked about biomass, but if we're switching the heat pumps and electrifying things, we're going to have to figure out how we can get solar as part of the equation. So, and we're going to go through just a couple of ways, and then I will also address some issues about solar also. Let's go to the first one there, Tom. So obviously we can do trackers, and trackers I have found are a great way to produce energy, produce electrons if you have limited space, because what it does is it tracks the sun wherever you need it. If I'm on a lot that's a fairly large lot, I found it more cost effective to put fixed ground mounts and just add a few more panels that would make up the 25% extra production from a tracker. Cost effectively, the trackers are a lot more money. They also have a lot more, well, I don't know if there's a lot of maintenance, but they can break down. And you've probably all seen trackers that forget where the sun is on occasion, and they have to go out and be taken care of. So ground mounts, in my mind, if you have the room on the particular lot where the house is, makes more sense than doing a tracker. But these things are excellent by way of getting more production. I've heard anywhere from 25 to 30% more per panel because it's tracking the sun. Next one. And on this particular, I also want to point out the color of this panel. The color of this panel, as opposed to the one you just looked at, is what they call a black panel. And they're a little more expensive. You have to pay a little more of a premium for them, but they're actually on an existing roof blend in a lot better. So if we're concerned about historically making these things kind of disappear, I would go to the next slide, Tom. Yeah, you could put these black panels on a roof, in particular a dark roof, and they kind of blend in. This is a low profile crystalline panel, but these panels, if we just did a building in Heinsberg called the energy, it's the middle of Heinsberg. It's a black roof, and we put these panels on in the black color, and it's really blends in, I think, pretty good. It doesn't jump out at you like some of the other ones that have the silver dots all over them. And that's the EFG, Energy Futures Group. This particular style is actually, I've done it on a bunch of houses, and it's a laminate. It's a thin laminate. You actually, before you put the roof on, the metal roof on, you attach the laminate to it, and then as you install the roof, it goes up together. And then on the top, underneath the ridge there, you click the connectors together and you loop one panel to the other. The homes I have done, I've had, when I was showing people, they would actually come up and say, oh, I thought these were solar homes, because they're looking for the panels. And then it was a darker roof, and I said, take a closer look up there. You see that little seam there? They said, oh, that's the panel. So these are probably the, you know, the Cadillac in terms of blending in, particularly if you do with a dark metal roof. That's really hard to pick out sometimes in the sunlight where the seam is. The unfortunate thing about this, this was a company that I used in the past. It's called Unisolar, and when they started making the crystalline ones, the ones that sit on top of the roof, more efficiently, and the price per watt went way down. They couldn't. The manufacturing of these could not keep up with the ability for them to put the wattage out there at lower cost. So the Unisolar went chapter 11 on us, and I didn't use them anymore. They are a little more costly than the crystalline ones. They were, and you need more space. The output per square foot, the wattage output per square foot was less than the crystalline, so you needed more room. So if you have room, if you're doing metal and you have room on the roof, this is a great way to go to really minimize the visual impact of the panels, particularly.
Do you know how much more you need of this than the crystalline?
Tom, it's been a while, but I think it's about 15% more square footage than you would, 15 to 20% more square footage. Yeah. The good news is that the company is trying to, or another company is getting back on track to do laminates, for the very reason that a lot of designers and architects are looking at these. And with metal roofs, this is the preferred, you know, aesthetic for a lot of buildings. And this is the Thetford Community Solar Project. I think it's online now. I think it was done on an old landfill. When we were encountering houses that, you know, had a beautiful maple tree in the front, or was orientated not correctly, we were suggesting that our clients actually look into getting community solar to balance, you know, the load for the heat pumps and plug load with the PV, but it does not have to be on their roof. So if we have an historical building that PV would just kind of distort it a bit, community solar might be a real option. There are community solar projects that are popping up all over the state. I know there's one in Bristol in Green Mountain Power territory right now. I think it's called Acorn 3, that allows people to actually buy panels in the community solar project. And I do believe you get the production, whatever number of panels you put in there, you get so many kilowatts per year out of that. They're your panels, you buy them. I believe depending on how the community solar is set up, you can evenly benefit from the federal incentive for that, 25% of the cost of the panels. But each one of these systems, these community solar projects, are set up and have different financial arrangements, and you'd have to check in with them to make sure you understand how they're doing it. There are some that will lease the panels to you, and you just get a reduction in the rate, but at least you're assigning whatever load you have for your house to solar, and that's how we would see you getting to net zero. If your house is not orientated, or you have trees that are not going to allow you to get production on site, or if you're in town. If you're in a tight space in town. I had some students from UVM one time do an analysis of random analysis of the buildings and all the structures in town and around randomly picked houses in Heinsberg and Richmond. And we asked them to pick out the orientation of it and trees. And we found that 25% in both Heinsberg and Richmond of the homes we looked at had no capacity for solar at all on site. So that's a small sample size, but I would venture to say that, you know, there are a lot of even small towns like Heinsberg and Richmond, there are a lot of homes that just don't have the ability to go with solar, and community solar may be the only option. And something like this, putting it on a landfill, Heinsberg, we're doing one in Vermont Electric Co-op territory on our landfill, and we're advertising it. And that one will be a project where you can buy the panels, and they're yours. So that's a great way to get us all to net zero, even if you don't have the ability to put solar on your building.
We just want to emphasize that in order to get to that 2050 goal, it's going to require embracing renewable energy, which mostly will be renewable electricity. And of course, solar isn't the only renewable source out there. There's wind, you know, either individual wind is an option for some people, or there may be some small community wind projects available as well, where similar to some sort of group net metering arrangement that you would do with solar, you could do the same thing with wind. But where renewable electricity doesn't completely fit the bill, we do consider biomass to be a useful option, and maybe it's only an interim option, I don't know. But again, there are a lot of reasons to support it in Vermont, provided it doesn't get too large and have too much of a deleterious effect, either through carbon emissions or through bad agricultural practices.
One thing before we leave renewable electricity, Tom.
Yes.
We are going to have to deal with the concept of storing electricity through the winter. If we're shifting a good percentage of our homes to thermal energy by way of heat pumps, the winter is going to be a tricky time to get through, and we will need to consider some form of storage, battery storage on small scale and large scale. That's going to be the new challenge as we move more and more into electrifying our homes.
Will we be able to get through the winter with battery storage?
Probably not. Nope. If we don't have the grid, we need the grid, but if everybody's demanding it from the grid.
I think we need grid partnerships with people in other hemispheres. I guess the southern hemisphere specifically. So there's lots of opportunity for thinking outside the box on that issue. Again, just things to keep in mind about renewable energy. The renewable load is the last load to be determined. Keep in mind heat, appliances, also electric vehicles. They're coming in a big way, and they have to come. So we want to be able to charge our electric vehicles if we're going to have cars. And keep in mind, there are other ways to be renewable: solar hot water, which Chuck has panned pretty much, and biomass heating and biomass hot water. Again, probably on a much smaller scale, but reasonably viable still in Vermont. The other thing about Zen that we really want to talk about, just very quickly, I've only got 2 slides on it, is the importance of making this energy transformation affordable. Again, if it's not affordable, it's not going to happen. And even right now, when we're only sort of trying hard, the incentives that are out there are amazing. We've run probably 10 or 15, maybe 20 projects through the Zen program to see what sort of incentives they qualify for. And it's very easy to get over $10,000, not terribly hard to get over 20,000. And the highest one that I've seen so far was $38,000. That project sadly did not go through because it was in Burlington, and there are in fact no community solar options available in Burlington right now. But again, the incentives are amazing. The reason that one had such high incentive returns was that they had a duplex and they were going to put in 2 furnaces and 2 hot water heaters. The furnaces actually were going to be centrally ducted heat pumps to replace forced hot air furnaces. But again, on incentives, they're very, very strong right now in combination. When you do a Zen project, you can, collect them all. I mean, you can just go out and pick them off of, wherever they are. In terms of financing, in order for Zen to succeed, again, we're going to have to just rethink our attitude about debt. I think of a Zen project as a little bit like buying a home as opposed to paying rent. Basically, you are investing in your home instead of, paying for fossil fuel somewhere. And an investment, even if it's over a long time, is a better use of your money, because at some point you get it back. So we need to sort of rethink our attitudes about debt around this kind of energy transformation. It may or may not be obvious that the longer the loan term, the lower the payment. Obviously, the lower the rate, the lower the payment too, but a slightly higher rate at a longer loan term is frequently lower than a slightly lower rate at a shorter loan term. These are just things to think about that are going to become important, and we have to one of the things we're going to have to do to get Zen taken up on a large scale is change the culture a little bit, and that means getting people to recognize that solar really needs to be important as part of it. In particular, as Chuck was saying, you need to be able to buy in to your power generation. If you're going to get rid of that electric bill, you have to own your generation and make that electric bill go away. And I know the utilities don't like that, and they're going to fight it. And I know that utilities provide very significant benefits. Certainly, if you're net metering, you're using the grid, you're using utility electricity, and they need to get paid for that. But somehow or other, owning your generation is going to have to be an important part of making this energy transformation work. And you obviously get the fossil bills right down to zero, cut the pipe, remove the tank, get off of the stuff.
Before you leave, can I just make one plug for Energy First Mortgage?
Sure.
So in terms of financing, there is a new pilot program being put out by VSECU that if you are going to refinance your house, if you want to put 10% more onto the refinancing, or use 10% of whatever you're refinancing to put into energy work, they will reduce your loan percentage by 0.5 point. So there are some significant options now for people who have a mortgage and want to refinance to do some of this. In addition to all the incentives Tom talked about, there are some financing options that are being piloted at the moment. I do believe the banks, and this is a DOE sponsored program right now, and they're just piloting it for this year, but they'd like to expand that to next year and maybe even look at beyond just refinancing clientele.
I was interested in joining this discussion because I had been talking to somebody who had just purchased a very nice old Queen Anne Victorian in Bellows Falls. And he was very interested in basically trying to prove that a house like this could take on a Zen project. He bought it at an incredibly inexpensive price. It's on a small lot that is basically surrounded, it's kind of a triangular lot at the intersection of two streets, one of which is Route 5 in Bellows Falls. So it's very urban in that sense. And it's right in the Bellows Falls Neighborhood Historic District, a very classic Queen Anne Victorian. He probably, wasn't super concerned or motivated to preserve historic elements of it other than sort of what immediately meets the eye. And he's made some significant changes inside, but he was very interested in trying to figure out if it could do a Zen project. So I was interested to take him through his options on that. I also started doing this a few months ago and hadn't had the benefit of all of what I learned about this morning before making some of these suggestions. So like Chuck, there are probably some considerations that maybe are frowned upon in terms of historic preservation best practice. This is the back side of the house from the other street, and you can see it's got kind of an interesting backside, many fewer windows. It's very narrow on that end. And these are actually just street view photos. He sent me some updated ones, which I'll show you later. He just bought the place, I think, in December, and this is what it looked like when he first moved in. It's got some classic features. I mean, this house was probably built in the 1890s. Bellows Falls had kind of an economic heyday at that time. It was a thriving mill town and transportation hub on the railroad. And I'm not sure, I don't know really much about the level of wealth in town, but there are a lot of these houses around in Bellows Falls, and a lot of them have fallen into disrepair. And it's interesting because I look at the handiwork that goes into a house like this, and all I can think of is the economic divide between the people who could live in a place like this and the people who were obviously doing the work to build it. Craftsmanship of the sort that you see here could not have been at a premium because there's an awful lot of it in here. So the place somehow had a lot of character. This furniture here is not the new owner's furniture, so I'm not sure what happened to it or really who owned the house before, but they look like they'd been there maybe for a long time. Some windows upstairs seem to be newer. I'm not sure These do not look like original windows, although the casing around them certainly probably does. The layout upstairs is very broken up. I don't know how many bedrooms exactly, but like sort of a typical Victorian, probably 3 or 4 rooms upstairs. A very tight little stairway, and there's also, here's the bottom of the stairs. This is the foyer. This is the front door that faces out towards Route 5. And then that's what I wanted to see. That's an upstairs bathroom. I had a bathtub like that in Burlington, and my mother always wondered what I looked like when I was in that tub. The attic, I guess, is going to stay an attic at this point. The owner had talked about possibly moving the envelope up into the roof, but I think perhaps he's decided he doesn't really need the space up there anymore, and so he's planning on just re-insulating the floor, and I don't know what the plan is on that. It's not actually included in any of my tool scenarios, because I was assuming that we would be basically putting foam in the roof. But you can see, the house is well built. Those are pretty good sized rafters. I can't really tell. I think they're probably 2x6. They might be 2x8, but I'm guessing 2x6, which on a pitch that steep is probably pretty safe. But you can see it's a small space up there just by the height of the person standing there. And there are a couple of those nested gables where it's even tighter, smaller. Framing mostly seems to be in pretty good shape. Now we get into the basement. This is a fairly common practice where you have the fieldstone foundation below grade and then brick foundation above grade. And I believe this is bearing load supporting brick. There's nothing else in there, and on the outside it's painted brick, and there's a big shelf that it sits on that supports that's the top of the fieldstone beneath. The fieldstone is, I guess, cut stone. It's fairly tight. Well, not super cut, but you get the idea. Well mortared anyway. And this is a bulkhead. This is one of the things he was interested in fixing up. And you can see there's been some effort to tighten up, the above grade portions, getting foam into the joints and that kind of thing. The owner's original plan was to use foam above grade and down. He wasn't going to go all the way to the floor, he said. Now he's talking about, I hate that stuff so much, not sure I'll do it. I don't think he'll be able to qualify for Zen without insulating the basement. This is the existing forced hot air furnace that is oil fired, and you can see it's good size system. And then the electrical panel, which is fairly new actually, but would certainly have to be, most likely have to be upgraded. Well, actually, no, it won't have to be upgraded because he's going with community solar, but it would probably have to be upgraded to accommodate heat pumps and a heat pump water heater. He did get one, he actually got 2 bids for the envelope, which included an energy audit and a blower door test. You can see at the top here, all of the items listed on the left have a cost here. And then these items are the ones that the owner opted for. These were ones that I think I potentially suggested adding, or at least thought we ought to review through the clear tool. And then these were ones that were rejected by the owner. And the only one that I sort of left in the rejected column, he rejected the full height basement wall foaming option, and he also rejected insulating any of the exterior walls. I had put those back in as potential adds to see what would happen if we ran them through the Send tool, through the clear tool. I concurred with rejecting the custom insulated door. He said he would do that himself. So that will happen anyway, but it won't cost $1,250. So basically, he was proposing to get rid of all the fiberglass from the underside of the floor, to install 20 mil vapor barrier over the dirt. There's a small dirt area, and run that up the walls so that spray foam would be sprayed over it and it would be sealed in place. He recommended spraying 3 inches close cell foam in the rim joist and down the full height of the walls. And then the main basement, also 3 inches. Closed cell foam in the perimeter rim joist and down the exterior foundation walls, a total of approximately 4 feet. He's going to cover all the foundation windows with 30-pound felt and insulate over them. I guess that's so that you don't look at a foil-faced piece of insulation through the window when you look at it from outside. And then putting intumescent fire-resistant paint on the foam. And then there was also the full height wall option, which he rejected. For the exterior walls, he was suggesting selectively removing clapboards to permit drilling holes in the sheathing to deliver dense pack to all the stud bays. And then there's some discussion about areas where shingles are installed, which is there's a belt course and of course the gables, which are actually mostly in the attic. So, but originally the plan was to insulate the attic. So that may be why that was important. And then all the holes be plugged and the siding reinstalled, patching and painting not included in this price. That's what he was going to do, netting and blowing the gables of the attic. Keep in mind that for purposes of the clear tool testing of these various options, that I was assuming the attic would be included in the envelope. And then of course there are these odd areas. The porch ceiling on the front extends back under the floor of the second floor. And then there's a similar detail on the laundry area in the back. And then the bay windows on the first floor have little triangles of floor above them. They're connected to the second floor. It looks like they were going to drill holes in the ceiling boards of that porch, which I suspect is because it would be difficult to remove the ceiling boards themselves. They're probably tongue and groove, and they're probably pretty brittle and old. So it would in fact be challenging to do that. I don't know what, insul cubes, those are things to block bays in the floor framing so that the cellulose is kept in the perimeter in those areas. And then obviously patching and painting would have to be included, and the same detail at each of the 4 overhangs above bay windows. And I guess the dense pack in the cavity above the rear laundry room, I'm not sure. I'd have to look more closely, but obviously there's a area back there that needs to be insulated that is included. And it looks like the owner agreed to that option as well. And then the attic was 2 options: blowing dense pack cellulose in the enclosed roof slope that extends over the front stairwell and hall closet, remove flooring from the perimeter of each chimney, seal the perimeter of the chimney with fire caulk and mineral wool, blow dense pack cellulose beneath the attic floorboards. Build a dam around the stairwell, blow an average of 12 inches loose fill overall, so the attic would be rendered no longer an attic by this unless they were to build a floor over this additional layer of cellulose, which I have done in some cases actually, and it's a good option if you want to get extra insulation in an attic where you have a floor that you don't want to take out. And then the attic option 2 is closed cell foam within the rafters of the roof slope. The rafters are strapped or padded down to allow 7 inches of foam. So obviously the rafters are 2 by 6, which means they're probably 5 7/8. And I think he agreed with that idea originally, but I think he has since changed his mind. I asked him for confirmation of that in an email, and he sent that to me just last night. So, but anyway, out of a $57,000 potential work scope, he chose $20,000 worth of stuff, not including the change now made to the attic floor. Again, since all of my renderings of the tool are using this number here, I think we should stick with that. So I will move forward. He's since spruced the place up a little bit. This is obviously not what it looked like in the 90s, I'm guessing anyway, but I mean in the 1890s, but I might be wrong, I suppose. And he's done some other work, quite a bit of work inside. You can see this space here is this space up here. What he did was, no, excuse me, these are 2 completely different spaces. Never mind, but he has been taking out walls and expanding doorways. This living room space, excuse me, this space down here is actually this space over here. This space, this very dark room that we're standing in here and looking out towards a much lighter room, is now this kitchen that was moved into what was previously a dining room. And this space here, which I'm not sure what it was considered before, perhaps a parlor, they now call a family room and have it just wide open there. He's obviously making serious efforts to preserve the Victorian, the traditional elements of the exterior, but less so of the interior, which of course is his choice. This is looking the other direction from the family room towards the kitchen, where it obviously looks quite different. But one advantage of opening up these spaces is that it allows the heat to circulate better in those rooms. And I think that is the end of my tour of the house. What I'm going to do now is
So we do need to talk about this third part of the equation, which is legality and matching and conforming with Vermont's rules. I was just checking this because I couldn't remember the exact answer, but there is an uncomfortable lack of hierarchy between building code and the energy standards because fire safety does not oversee the energy standards, and that's still to be resolved. I think that's one of the things the legislature has been talking about is who is tied in with enforcement. They come down to kind of the same thing, which, well, I think that this is for fire safety, that for major rehab, you look at chapter 43 of 101. So the designers probably all know what I mean. We don't use IBC as the dominant code for existing buildings in Vermont. And the difference really is that in NFPA, there's a little more presumption that a building has historic significance. The IBC family, which generates the IECC, which is our Energy Codes Basis Foundation, is more kind of, it's more exclusive. You have to prove that you're significant. And that was what I was getting at this morning. Especially in this growing age of diversity and understanding that a very small story in the midst of much larger, stories is significant in its own way. It may be significant in its humility. You mentioned this house in Bellows Falls, Tom. 80% of all houses before World War II were built by their owners. And usually those homeowners had those skills to do that level of craftswork, or they might have known someone locally. And it's really now the provenance of someone who's super wealthy to have a really elaborate trim inside or outside a house. So I personally feel that question is significant. And I've asked Elizabeth or Laura to speak to just how permissive are they? Because so what happens is you can look at the chapters on existing buildings, which then leads you to historic buildings. Residential and commercial have aligned that there is a form that is required now. Here's the beginning of the form, and it's a 2-page form, and it gets submitted to Division for Historic Preservation, and then they make a decision. Now, so the question is, can you avoid this altogether? And the answer really is, if you're doing work on part of the house, that part of the house needs to conform to the energy code. It also, if it's commercial, needs to conform with the building code. And so to straight out take that off the plate, not be worried about it, you have to get this approved. If you're in an historic district, it's a lot easier. If you're on the edge of a very small village, as we mentioned about the Pittsford house earlier, it's a little bit more of a challenge. You probably,
Sandy,
yeah.
can I chime in?
Yes, please. I was hoping you would.
I was hoping you would, Elizabeth. Thank you.
Hi, I'm Elizabeth Peebles. I'm on the project review team with the Division for Historic Preservation. So most often I'm the one reviewing these energy exemption forms for historic buildings. And I think one important thing to keep in mind with these exemptions is that there's no requirement that you pursue the historic exemption. We encourage it to be a part of the design professional's consideration, especially when the energy standards might impact significant historic features adversely. And so that's when you would look into the specific provision in the code that your property owner or your design professional or your preservation consultant has concerns about. And you would identify if you think your building might be historic, you may already be listed, or it could be that your building's never been evaluated for the state or national register of historic places. That should not be an impediment to you considering using this form. That's what our office is here for. We can help with that evaluation. And part of the form is us identifying if the building has historic significance. And so we might ask follow-up questions. We might do a little bit of research. But the key thing for architects and energy retrofitters that might be filling this out is identifying the specific part of the code that you think will adversely affect a historic feature. Because that is what we're going to zone in on. We're not looking at exempting the whole building from energy code, just those changes that might adversely affect historic fabric that is important to the homeowner and they want to protect. And then you can also use this for commercial as well, especially with some of the industrial warehouse retrofits where, keeping exposed surfaces, so not finished spaces, is maybe part of the vibe that the new business wants and is also a part of the historic character of the building. There's really nowhere to put insulation in a wall, but then you can find other places to maybe meet your energy goals, but still preserve that historic fabric that you want to keep and honor. So so then you send the form over to our office. We let you know if we have any questions, we fill it out, and then it's a part of the certification that you met the energy standard.
And this is not really trying to avoid weatherization or energy conserving at all. It's taking some of the numerics out of it. And a lot of owners use the prescriptive paths, which are straight up numbers, like your walls have to be R20 and your roof has to be R49. There's a lot more latitude with the res check and hers in particular. But this lets a person, a homeowner, focus more completely on a goal like net zero energy. So I think that it's really good. I personally am really trying to push the way I can as an individual to get the state and hopefully the whole nation to be thinking more inclusively about older homes rather than making it a very difficult process to honor the historic fabric. And I'm really hoping that this larger picture of net zero is one way to address that. I think that there's a lot of discussion going on about if any kind of combustion is allowable or should be allowed, including wood combustion. I think there's room in our state in particular with our forestry history for thinking about local solutions to combustion. As Tom said earlier, especially if it's in proportion with a whole lot of non-combustion strategies. But these questions can't start to develop unless we begin to think about historic buildings having some value, the embodied value, energy value that Judy and Alex mentioned earlier this morning. The buildings themselves have embodied carbon, and they've also, they took very little energy to make, plus they exist already. Thinking about local economies, as I said, and also net zero. So this is a little bit of a plea to every single participant to please become a little bit more proactive about this balance. And again, it's not about shirking our duty to save the planet. It's not about that at all. It's about opening up the conversation and kind of getting out of the cookie cutter approach that yes, it's fast and it's furious and boom, 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 but it is, we are losing things in the process. If you look at the North Branch Nature Center that I showed earlier this morning, there's a loss there. And it's imminent on many, many buildings in Vermont with this real effort to retrofit the entire state, which needs to happen, but let's do it in a larger context. Okay, I get off my soapbox now. We have just a few minutes if anyone has questions. Sorry, I talked a little too long there.
No, Sandy, I think what you were saying is spot on. And I think, it is about kind of taking a more holistic kind of approach to how we think about energy usage. And, and maybe thinking about how, what's the impact on the environment of all the XPS foam that is being produced? Is it better for the environment to use mineral wool or something like that? And what are the long-term kind of outcomes of using all these materials? Like, what will the foam become in 50 years, as opposed to what will the cellulose look like in 50 years? These are all questions that I think we just need to start asking as we move forward.
Alex, to pick up on that a little bit, this is Chuck. I'm also a fan of cradle to cradle. So when we think of materials like cellulose, when we have to renovate a building or change it, we take the cellulose out, put it in a bag, and then put it into the new area that we just built, or those types of things. Whereas foam goes into a landfill and lasts for 10,000 years or whatever it is that degrades. So thinking about not only preserving and embodied energy, but also can we reuse all this stuff that we're pulling out of here, which they used to do with barns. Somebody would take a barn down and it would put pieces that would pop up, down the road. That's the kind of sustainability I'd like to see happening.
Chuck, I insulated my first house with repurposed cellulose that I took off of a previous job with the owner's consent. I'll throw in, but you're absolutely right. I think that's a great way of thinking about it.
Yeah.
I'd like to recognize Doug.
Okay, yes, thank you. Chuck, just a question for Efficiency Vermont. Are you off the net 30 and now on the net 50?
Net 50 seems to be a compromise. When years ago.
Thank you. Yes, thank you.
Well, years ago, just to let you know, years ago when they were doing the comprehensive energy plan, we argued for 2020, and then we bumped it to 2030. New homes it's still in the comprehensive energy plan that it's net zero by 2030, but I'm not sure we're going to have enough time if we're pushing it out to 2050. It's a compromise, and I will still push back and say we have to do it sooner.
It's still a pretty steep ramp, though. That's all I would comment. It's hard. There's a lot of professionals that are in it, and they're really in it, and then there's some of us that go in it once in a while, and it's really hard for us once in a while guys to come up to speed. I'm more in commercial than I am residential, but now you're even pushing on the commercial envelope. So I would just say thank you for bringing the ramp down a little. And I think if the ramp is a little lower, the costs increase will be a little more moderate, because the quicker the ramp, the higher the cost. I think it's all going to go back on, the homeowner. And I don't necessarily worry about the upper income homeowner or even the upper middle income owner. I worry about the lower level income owners. They're just not going to be able to afford this stuff. It's going to be pretty tough on the lower income Vermonters, I feel. And I am a Vermonter. I live down in Windsor, and I do most of my professional work in New Hampshire, which is quite a bit different than New Hampshire, than Vermont. So again, it's just a comment, and I just wanted to thank you guys for bringing the ramp down a little bit. And one more thing, just while I got your ear. So if I've got a $250,000 turn of the century house, and I want to renovate it, what is the threshold for actually having to meet 100% of the energy code for that old house? Is it used to be based or assessed on the value of the house at 50%? So if I put if I got a $250,000 house and I put $125,000 in it, then I need to bring it up to code. Is that still the assessment, or is there language somewhere that's pretty specific on this?
Yeah, it's chapter 4. It's chapter 4 of the residential, or I don't know what chapter it is in commercial, but it's very specific. I mean, if you're replacing a window, the window needs to comply.
Correct. Yeah, I get that. I guess I'm looking at partial versus full house renovation.
Oh, at what tipping point is it considered a total redo?
Correct.
I think that is in here.
It's very hard to find.
I just took a couple of excerpts. Oops, I just took a couple of excerpts out. So,
and
it's in the code.
Yeah, I've not argued, but I've debated with a couple of AHJs on it in the past. It's very subjective to some of the AHJs.
Yes, that's actually a problem too.
All right, I think we have 2 questions left. We're going to run just a little bit over, but I wanted to recognize Rick Kirschner.
Yes, for those folks that have had a lot of experience with mini splits, are you seeing any type of maintenance problems, where people have to come back in or are they pretty dependable? You can just install them and forget them.
This is Chuck. Do not install them and forget them.
Exactly.
If you forget them, the dust will build up and your efficiencies will go way down. So
not only that, install them and learn how to use them.
Yes.
How about with contractors coming in to tune them up or to check in if they're not cooling right, or they're pretty complicated pieces of equipment?
Yeah, I can speak for myself. We've had one system that we had to go back in and somebody checked the coolant, everything was fine. The only problem was they didn't clean the filter. Okay. And once they cleaned the filter, it went right back up. So I have not had a lot of issues with I deal mostly with Mitsubishi, but in terms of losing coolant or anything like that, I haven't seen that. There is maintenance though. You do have to keep on cleaning the filters. Yeah.
Okay, and then I think Jethro had one last question, and then we really should wrap it up.
Sorry, real quick. I was just curious if, like, part of a state bill of trying to, if there was more incentives getting pushed through for energy updating old buildings, and if anyone was aware of that.
I wish Steve Spatz were with us still. He could sum it up very quickly. I think they're changing all the time. I heard that there's a new incentive starting for geothermal, which is wonderful. That is definitely behind in our state, partly because of the lack of drillers. So I can't answer that. It seems like Steve is gone, so hopefully some other time.
And I think we'll try to take a look through the questions and try to get things to the right person, right panelist or speaker, and see if we can connect those who asked questions, because a number of good questions have come in this afternoon that we're just running out of time. And but I want to thank everyone. And also a parting thought that I want to leave you with is that it's not about historic preservation or energy savings. A really key point is that historic buildings are severely impacted by climate change. They have a propensity for being located near large bodies of water. So they are at greater risk for floods, and they're at greater risk of rising sea level. And so this is not about, hugging our buildings over saving energy. We really are in this together. And the other piece of this is that much about what we preserve has nothing to do with aesthetics. It might not even have anything to do with quote unquote historical significance. It has to do with traditional building practice. And much of what was created historically was born out of the wisdom of builders who understood their region and they built accordingly. So, and we have many lessons to learn from that about what is truly sustainable in the future. just as there's new technology in the form of heat pumps and the computer program and being able to use something like Zen to help us make good decisions. So it really is a balancing act. And if you take one thing away from you today, take away the notion that we are in this together. And hopefully we've set an example for you here today. Even if we can't always agree on every detail, we want to listen to each other respectfully and learn from each other. So I want to thank all of the panelists, our sponsors, Vermont Gas and Efficiency Vermont, Preservation Trust of Vermont, Build Safe Vermont, and Sandy for all of her hard work at organizing this event. Chuck and Tom for talking, Alex for sharing his wisdom. It was a jam-packed day. And most of all, we want to thank you, the attendees, for really great questions. And we were so worried that this wouldn't be interactive, and it was interactive. And that was because you were willing to participate. Thanks very much. And any final comments, Sandy?
No, thank you everybody for being so patient listeners.
All right.
Take care.
Thank
All right.
you, guys. That was
Bye.
great.